Water is essential for all life. From the smallest bacteria to the largest whale, every living thing needs water to survive. Our planet, covered in a magnificent blue expanse, is teeming with life, thanks to this miraculous compound. Water is more than just a drink, it is the lifeblood of our planet. Water makes up about 71% of the Earth's surface. It is a key ingredient in cells, tissues, and organs. It helps to regulate our body temperature and carries nutrients throughout our systems. Without water, life as we know it would cease to exist. Water is a simple molecule made up of two hydrogen atoms bonded to an oxygen atom. This combination forms a V-shaped structure that is fundamental to its unique characteristics. But don't let its simplicity fool you. Despite its small size, water has a profound impact on our planet and all living organisms. This tiny molecule possesses extraordinary properties that make it unlike any other substance on Earth. From the vast oceans to the smallest cells, water is essential for life. The secret to water's unique behavior lies in the way its molecules interact with each other. These interactions are the key to understanding water's versatility. The hydrogen atoms in a water molecule are slightly positively charged, while the oxygen atom is slightly negatively charged. This charge distribution is crucial for water's properties. This creates a dipole moment, making water a polar molecule. Polarity allows water to interact with various substances, making it an excellent solvent. These opposite charges attract neighboring water molecules, forming weak bonds called hydrogen bonds. These bonds are constantly forming and breaking, giving water its fluid nature. These bonds are responsible for many of water's remarkable properties, including its high boiling point, surface tension, and its ability to dissolve a wide range of substances. Without these properties, life as we know it would not be possible. Water has an unusually high specific heat capacity, which is a measure of how much heat energy is required to raise the temperature of a substance. This means that it takes a lot of energy to raise the temperature of water, making it an excellent heat buffer. This property is crucial for regulating temperatures on Earth as it helps to stabilize the climate. Large bodies of water, such as oceans and lakes, can absorb and store vast amounts of heat from the sun, acting as thermal reservoirs. This helps to moderate temperatures on land, preventing extreme fluctuations between day and night and across seasons, ensuring a more stable environment. Water's high heat of vaporization also plays a vital role in temperature regulation, as it requires a significant amount of energy to change from liquid to gas. When water evaporates, it absorbs a significant amount of heat from its surroundings, providing a cooling effect. This is why sweating cools us down, as the evaporation of sweat from our skin removes excess heat from our bodies. One of the most peculiar properties of water is its density anomaly, a fascinating characteristic that sets it apart from almost all other substances. Unlike most substances, which become denser as they freeze, water is actually less dense in its solid state, known as ice, than in its liquid state. This counterintuitive behavior is what makes ice float. This is because the hydrogen bonds in ice form a crystalline lattice structure that keeps the water molecules farther apart than they are in liquid water. This open structure is what gives ice its lower density. This unique property has profound implications for life on Earth, especially for aquatic ecosystems that rely on this anomaly for survival during cold seasons. If ice were denser than water, it would sink to the bottom of lakes and oceans, eventually freezing them solid from the bottom up. This would drastically alter the environment. This would make it impossible for aquatic life to survive, as the entire body of water would be frozen, leaving no liquid water for organisms to live in. However, because ice floats, it forms an insulating layer on top of bodies of water, protecting the organisms below from freezing temperatures. This insulating layer ensures that life can continue to thrive even in the harshest winter conditions.